This is Mastering Mathematics with your teacher, Karen Weston.
Good evening. This is Karen Weston, your mathematics teacher, welcoming you again to Mastering Mathematics, program sponsored by ABS Television and the Education Broadcasting Unit out of the Ministry of Education. This is what it's all about. We've got to train our students, we've got to train our teachers, we've got to train the whole world, because in these days we're talking about knowledge economy, and what is running the engine? It's knowledge. And what do we know mostly? Mathematics is the foundation for everything. But we're not just going to wait until they reach the secondary schools to start teaching mathematics. And I have some guests who have been very, very patient because they've been watching every week. And from the time I did number theory, it seems as if I left them out in the cold. Yes, those are our primary school children. They too want a piece of the action. And they are willing because they are ready to show us that they too can do mathematics. What did we say we are doing? Algebra. Do we do algebra in the primary school? Yes, we do. But we don't call it that name. But there is a branch of the mathematics in our primary department which deals with algebra. So that when a teacher says to a child, and students, see if you can do this. If I say 3 times a number is equal to 48, and ask you to give me that number or to find the solution for that number, that is algebra. So, are you willing to try that for me? Okay, so let's hear it then. And this belongs to our primary department, and you'll be surprised to know that some of our senior secondary students are also having difficulty, and you, my primary students, would give them a run for their monies. Okay, so we are saying 3 times. So if we had, the first thing we're going to say, let the number be equal to x. So therefore 3 times x would be equal to 3x. And what did they tell us? 3 times that number is equal to 48. So we're setting up an equation that says 3x then would be equal to 48. All right? And your teachers in your primary school would have been giving you 3 times box. Okay, that box is what we're taking away in the secondary school and calling x and y's. All right? So we're saying 3 times box is equal to 48. And it is that number that we're looking for. So if we get back to our equation, we have 3x is equal to 48. Because we don't want 3x, we want 1x. We're dividing both sides of the equation by 3. So we will be getting, it is 3x over 3 would be equal to 48 over 3. And we can cancel, and we're going to get x is equal to, and yes, those tables are important. Don't count no finger. All right? And that is why in our grade 2 and our grade 4 exams, I see them testing you on mental arithmetic. And it is important in the sense of just making certain that we can think quickly. Sure, you have your calculators. Sure, your calculators can take care of certain things. But it's always good to challenge yourself and to see that you can deal with things quickly. All right? So we will be saying our 3 into 4 goes once with 1. And 3 into 18 goes 6 times. You must say your tables as fast as that for me. Okay, I'm going to show you some tricks next week how you're going to get those tables going. All right, so right away we're getting then, yes, that our x then would be equal to 16. So you see, you two are taking care of algebra. That was easy. All right, make one of them, construct one for yourself, show your daddies and your mommies that you can do it. And the next time your primary school teacher asks, say, yes, I am doing algebra, because that is in the realms of algebra. And you are, in fact, doing your linear equation because you had to construct this every time you're doing something like that. All right? Now, let's give you another one because you've waited so long for this that we have to ask you some more questions. Antigua Barbuda, what fruit do you like most of all? I love those mangoes. Wow, belly. Lovely, lovely mangoes, all right? But I have a little nephew, and his name is Che. He likes mangoes too. So I went to buy some mangoes, and I gave him 5, all right? Che has 5 mangoes, and he is saying, Auntie Karen, the 2 of us has the same. No, I have twice as much of them, right? So he has 5, but I have twice as much as him. So what would that be? So if Che has 5 mangoes, now what does twice as much means? What do we have to do when we're talking about twice? Because that's not something. Yes, it is our 2 times table again. You see where those tables come in? We have to learn them. So it's not just to say twice, 1 or 2. No, it's to say, when am I using them? And you're using them exactly when I'm telling you, Che, I have twice. Don't say it hard, right? Because he thinks he has the same amount as I do. But that's not true. I gave him 5, and I have twice as much as him. So, how many do I have? Yes, I must multiply by 2 to see. So, my share. So, this is Auntie Karen here, all right? Yes, Auntie Karen. Okay. So, what would I have is equal to 2 times 5. And that is now equal to 10. Oh, do you think I'm going back to buy mangoes from that man again? Yes, for $5 I got 15, right? Because isn't that true? Che's share, okay, Che's share plus Auntie Karen's share, all right, would be equal to 5 plus 10, and that's equal to 15. Oh, that's a lovely, lovely, lovely sale. 15 mangoes for $5 in Antigua in this hard guava time, they will tell me. That is lovely, right? So, students, when you are given these things, again, you're doing algebra, all right? And we see that the tables are important, and especially for our exams. Show them that as little as you are, you can do it too, all right? Good. So that was your little part of it. And from now on, we are not going to leave you out. No, you're very, very important in this equation. So here we go.
Be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so that all your values are in the same unit of measure. For example, change all values to feet. When asked to show work or justify your answer, don't be lazy. Write down everything about the problem, including the work you did on your calculator. Include diagrams, calculations, equations, and explanations written in complete sentences. Now is the time to show off what you really can do with this problem.
Right. So daddies, mummies, and my fifth form students and secondary students, you got a breather, okay? Good. Now I'm back to test you to see if you can do this simultaneous equation. And after this, all you have to do is practice, practice, practice. Now, today we have again simultaneous equation, and it is 4x minus 3y is equal to 1. And that's equation 1. Then you have x plus 3y is equal to 19, and that is our equation 2. I specifically chose this equation because I told you yesterday that the coefficient from each equation must be multiplied in the opposite one when we have decided which variable we will be eliminating. Remember, the principle we said yesterday is that we're trying to make one of them 0. Sometimes in our simultaneous equation, once we are looking and we're minding our business, we can see that all we have to do at times is just to add, because we can get one of them eliminated immediately. All right? Can you see in this problem where we have negative 3y and we have a positive 3y, that if we add, because 3 minus 3 would give us a 0, that we really don't have to do any sort of multiplication, but just to say equation 1 plus equation 2, and then we can get our solution. All right, so let's go ahead and do just that. So our first statement here would just be telling us equation 1 plus equation 2, and you can do the addition with me. Here I have x, but what does this mean? What is the coefficient? Yes, it is 1. Remember, we said already you would never see from a seasoned mathematician 1x. So it is understood. That is what we say. So then it is 1 plus 4, which would be giving us 5x. Okay? And when we add in plus 3y minus 3y would leave us with 0. Right? So this is what we want to happen, because we must eliminate one of them as long as we're doing simultaneous equation. And then we're going to be adding 19 plus 1 would give us 20. And right away, we would be onto our equation 3. So then, what am I saying to you? It is not every time that you have to carry out this multiplication. The multiplications are carried out to make certain that we would have arrived at identical coefficients for the variables we want to get rid of. And then we would choose to say we are adding or we are subtracting. All right? In this particular case, this was an ideal situation. Okay? We could just look right away and see, oh yes, the y's have identical coefficient. The terms are opposite. We don't even have to change any signs. So the only algorithmic operation we had to perform was just the addition. Okay? And again, everything hinges on our 4 operation. Is it subtraction? Is it multiplication? Is it division? Or is it... So we said subtraction, multiplication, division, or addition. All right? So this time we were using addition. So we had 5x. So we said equation 1 plus equation 2. And doing that, we got 5x is equal to 20. Again, we don't want 5x. We want 1x. And in order to do that, we're dividing both sides by 5. So it would be 5x divided by 5. So it's always the coefficient of the variable that we're dealing with that we are dividing both sides by, okay? Because we want to make that the coefficient of that variable just the number 1. So we get 5x is equal to 20 divided by 5. 5 into 5 goes 1, so x would be equal to, and my primary school students, you can answer me, 5 into 20 goes, right, 4 times, that's right. So you see, you have a part to play too. So that for here, the value of x is equal to 4. Now you know already when it's our simultaneous equation, although I'm saying it because people may say, Miss Weston, for you that's easy, but I need a little time. So again, I'm going to give you a what